Okay, gentlemen, we're on 2.3, day 2. Here we go. Have your GDC ready, please, and also have your 2.3, day 2 handout ready. Here we go. So you can see at the beginning of 2.3, day 2 handout, we have, let me expand that, we have a question that you did in last unit. So hopefully, yes, you have your graph paper and your graphing display calculator. I'm going to write this question out twice because there are two methods and you might feel more comfortable with one of the two, but I'll just show you again. If you want to pause the video, see if you come up with the right answer on your own, that's what I would suggest. It's good practice for upcoming exam type thing, if we have an exam. All right, so one method that we learned was to look for a common denominator to get rid of the fractions. The lowest common multiple or lowest common denominator here, I look at the 5, it's the largest number, and look at multiples of 5 that work with everything. Okay, if you know your multiplication tables, you know the lowest common multiple that works with 3, 2, and 5, all denominators, is 30. So I'm going to multiply everything there by 30. This one here I couldn't really squeeze in, but it's supposed to be in front of the 1/2, okay? So when we multiply everything by 30, we basically want our denominator to all the denominators to come out to 1. Okay, in effect, we're eliminating them. So 3 divided by 3 is 1, and 3 goes into 30 10 times. 2 divided by 2 is 1, 30 divided by 2 is 15. 5 divided by 5 is 1, and 30 divided by 5 is 6. So what are we left with? 10 times x plus 2 plus 15 times 1, which is just 15, equal 4 times 6, which is 24. Okay, then distributive property gets me 10x plus 20 plus 15 equal 24. Again, sorry, it's a little bit of chicken scratch. I'm writing on the computer screen here. So if I simplify the left side, I get 10x plus 35 equal 24. And then I'm going to bring the 35 over, switch teams, change jerseys. Remember that? So this is 10x. Oops. That's really not coming out neat. 10x equal 24 minus 35 is negative 11. Then to eliminate the 10, or to get rid of it, we get divide both sides by 10, and we get negative 11 tenths. Okay. Method 2, you might find this one more interesting, is jumping a little closer to cross multiplication. Okay. But to first, we have to have fraction equal fraction to do cross multiplication. And right now we have fraction plus fraction equal another fraction. So let's start off by switching teams, changing jerseys. We're going to write x plus 2 over 3 here. And because the 4/5 was on the right side first, we write it first. And the 1/2 is coming over, it becomes minus 1/2. Now I have x plus 2 over 3 equal, and I need to come up with a common denominator here because we're subtracting fractions. And the lowest common multiple is 10. What did we do to the 5 to get to 10? We multiplied by 2. So we multiply the 4 by 2. 2 times 5 is 10, so 1 times 5 is 5. And we're left with x plus 2 over 3 equal 3 over 10, because 8 minus 5 is 3. Now I can cross multiply here. That times that equals that times that. So that's 10 times x plus 2 equal 3 times 3, which is 9. Then we have to distribute. We get 10x plus 20 equal 9. Bring the 20 over, and you get 10x equal 9 minus 20, which is negative 11. Divide both sides by 10. And once again, you get negative 11 tenths. Whatever method you prefer works for me, okay? Whatever works for you is good. So to create, the learning goal here is to create a scatter plot on the GDC. We did that last day, and we're gonna do it again today. And then we're gonna perform a regression. A regression is a fancy schmancy way of saying a line or curve of best fit. Line or curve of best fit. Now, last day, in the last video, you learned about this question here, how to use your GDC to make a scatter plot of this, speed and stopping distance. We talked about independent and dependent, right? The stopping distance is the dependent, that would be the y-axis, and this is independent, okay? Stopping distance depends on how fast you're going or your speed. Where in your textbook can you find instructions how to make the scatter plot? That is, just a double check, page 535. Page 35, 535 and 536 go over how to do the scatter plot and then how to create the line of best fit, all with your calculator. But page 535 is what you need to know for now. We're actually going to skip over to this question because the last one you did last day or last video. And if you want to test yourself, you're welcome to go do that. It's probably already in your calculator though, so it might not be much work to do. You might want to reset or clear your calculator and try doing that on your own, okay? So here we're dealing with a homework question. This shows fat and energy content in typical servings of fast food. So from Harvey's hamburgers to Mr. Sub to KFC, pizza, Swiss Chalet, and it gives us the serving size, okay? The serving size in grams, it gives you the fat, okay? It gives you the fat in grams, and then also gives us the energy, okay? And I'll highlight a different color here, gives us the energy in kilojoules, okay? Now the question is going to ask us to do a few things with this information. First, it's going to ask us here, calculate the amount of fat in milligrams per gram of each item. Calculate the amount of fat per gram. So let me leave this part out for a second, in milligrams. If it just wants the fat per gram, basically you're going to take that column, because that's the fat, and the serving size is in grams. It's not talking about energy yet. So you would literally just take, for example, for the first row, you would take 20 divided by 157. That would be fat per gram, and they're both in grams, okay? But this question asked us, through a curveball, it asks you for the fat, not just fat per gram, it wants the fat in milligrams per gram of each item. So we have to take the fat and convert it to milligrams. You might remember that 1,000 milligrams, that looks like a 6, sorry, 1,000 milligrams is equal to 1 gram. We're going from grams to milligrams, so we're going this way. So we have to take our 20, for example, here for the first option for Harvey's original hamburger, take the 20 grams, multiply it by 1,000. So it's 20 grams is the same thing as saying 20,000 milligrams. So we have to take every one of those numbers and multiply it by 1,000. Okay, but we're not going to do that just yet. We're going to let the calculator do some of the work for us. Then it wants us to round our answers to the nearest milligram and list the results in a table. Okay, we could do that. So what we're going to do is we are going to go to our trusty GDC. Let me just put that here. Okay, and you'll see that I have the GDC on the screen already. Now, if I go to my stat menu, hopefully you remember that part. If you're entering these statistics or this information into your calculator, you're going to need to use your GDC. Okay, and what happened to my graph there? There we go. All right, so if I go to my stat menu, click on stat, option 1 is edit. I've got information from the last question I did there last day. I want to get rid of it. The best way to get rid of it is use the arrows, left and right arrows there, and go up so that you're actually on L1, the title of that list or that column. And I want you to just hit clear, the clear button, and then enter, and that will be gone. Then tab over to the right and up so you're on list 2, the actual title of that column, and hit clear and enter. So clear, enter, and the whole list is gone. That's what you want to do. Now we're going to go down under list 1, the first row, okay? Not on list 1. We want to be underneath it now. And we're going to enter all 3 columns here. So list 1 is going to be the serving size, right? Sorry about that. List 1 is going to be the serving size. List 2 is going to be the fat, and list 3 is going to be the energy. So let's go ahead and I'm going to pause the video for a second and enter this information, and I'll ask you to do the same, okay? All right, so again, once you've entered all the information, you want to make sure all 3 columns or all your information line up so you don't have extra in one column than the other or too little in one column. Sometimes when you go to graph this information, it'll say error dimension mismatch because you didn't put enough in one column or you mixed up things, okay? So just double check that everything lines up, you entered it correctly, triple checking your numbers. And once you have that information, we can now start answering some of these questions. It says calculate the amount of fat per gram, okay? So let's really fat per gram. Now it wants it in milligrams, right? So we have to multiply it by 1,000. So we have to take everything in that column and multiply it by 1,000 and then divide it by the serving size per grams because it wants fat. Remember, if it was just fat per gram, we take, for example, for the first one, we would take the 20 divided by 157. But in this case, we're going to have to do, for example, 20 times 1,000 because we want it in milligrams, and then divide by 157. But we want to do that for everything in column 2 in that highlighted pink column, and then divide it by list 1. So what we're going to do is we're going to go to list 4. So go to your GDC and tab over to the right so that you're at list 4. And I want you to go up with your up arrow so that you're on the title list 4. Okay, so you're highlighted L4. You'll notice at the bottom of your GDC screen, it'll say L4 equals. And what that means is you're going to tell the calculator what you want it to do for that column. Okay, we're going to tell it to perform a calculation so that it'll fill in that column for us and perform all the calculations in one shot. So again, we're going to take now, remember, fat in grams is list 2, that purple or pink highlighted column. That's what we want to take. We want to take that entire list and multiply it by 1,000. Well, on my GDC, that's list 2. So what you're going to do is you're going to open a bracket on your GDC. So above the number 8 button, you'll see there's a bracket button. So open bracket, and at the bottom, you should see the open bracket on your GDC. And we're going to tell it to take list 2 and multiply it by 1,000. How do you do that? Well, above the number 2 button on your calculator, see in blue there, it says L2. It has a second function. So hit the second function button on your GDC and the number 2. And you'll notice that what shows up on at the bottom, list 2. And then hit times 1,000. So times 1000, and then close bracket. Above the number 9 button, you'll see there's a close bracket. So we took everything in list 2, we're going to multiply it by 1,000, and then we're going to hit the divide by button on your calculator and divide it by whatever's in list 1. How do you get list 1? Second function of the number 1 button. So we've got list 2 times 1,000 and then divided by whatever's in list 1. And that'll give us fat in milligrams per gram. Now, if you hit the enter button, boom, number 4 is calculated for you. All of list 4 has been calculated. Now you have to round to the nearest milligram. So in this case, the nearest whole number. So the first one, obviously 127 would stay there, 127, 63.38 would be 63, 33.52 becomes 34, 25.641 becomes 26. Just you need to know when to round up or down, obviously. And then what else does this question ask us to do? It says, calculate the energy content per gram of each item. Okay, so calculate the energy content, that's list 3. You might remember, right? List 3 is energy in kilojoules, energy per gram of each item. So it's list 3, energy per gram, list 1. So list 3 divided by list 1. So put your cursor at the top of L5, make sure you're on the actual title category, L5, and we're going to make it do list 3 divided by list 1. How do you do that? Second function of number 3 will be list 3, and then divided by second function of number 1. So list 3 divided by list 1. Enter. And there you go. It automatically calculated the the energy content per gram of each item. That's all done for us. Then it says make a scatter plot. A list of calculations in a table. Okay, the calculations are already in a table for us. You can just copy this on a table if you wanted to. And then it says make a scatter plot of the 2 sets of data you calculated in part A. Would you put fat per gram or energy per gram on the horizontal axis, and why? Well, does the energy tell you how much fat there is, or does the energy depend on how much fat there is? Right? It's actually the second one. So the amount of energy you're going to get from something depends on what the fat content is. Okay, so the amount of energy depends. Remember Y, God, Y. The Y-axis is going to be energy per gram is on the Y-axis. Fat per gram is going to be the X-axis. Okay, remember fat per gram in milligrams was list 4. That was list 5, the energy per gram is going to go on list 5 because the energy depends on how much the fat content is, the fat per gram. We calculated the fat per gram. Yeah, okay, so making a scatter plot of the 2 sets of data that we calculated in part A, that was list 4 and list 5, right? So how do we make a scatter plot of that? Remember, we want fat per gram, whatever's in list 4 is the X, and whatever's in list 5 is going to be on the Y-axis. So you may remember from last time, some of you guys, what you want to do is you want to go to the second function, hit the second function, and then y equals, that's your stat plot, making sure your stat plot is on. Now, if you haven't done anything with your calculator since the last video, your stat plot's already on, except you have to be careful. So hit enter here. Okay, so stat plot is already on, hit enter. If it wasn't on, you'd be hitting enter on the word on, but it's already there. You can see it's flashing. But what the calculator is doing is, see how it's saying X list L1 and Y list is L2? If we go to graph this, it's gonna take whatever's in list 1 as my X axis and whatever's in list 2 as my Y axis. I don't want that. So I'm gonna tab down with my arrows, and where it's to L1, X list, my X is actually gonna be list 4. So I'm going to hit second function and the number 4 button. See that? And I changed whatever's on the in list 4 is going to be my x-axis. And I'm going to tab down with my arrows again, and I'm going to change y list to be number 5, second function of number 5, which is L5. So now when I go to graph this, it'll work. Okay, so that's done. Remember, when we want to graph, we want to zoom in on our statistics. If I just hit graph right now, go ahead and hit graph on your calculator, you get something weird. But if you want to zoom in on what we just did, you hit zoom and option 9. So zoom and enter 9. That's zooming in on your stats. There you go. We've got our scatter plot. Looks pretty decent. I do see that this dot here at the beginning looks a little out of place. This dot here also looks out of place. So those are probably our outliers. So the next question says, identify and explain any outliers. Should they be removed from the data set? Well, not really. And I'm going to pull up the answer key for the sake of time here. I have it written for you. 2.3 day 2. Let me just expand that for you. Okay, so energy, remember, energy depends on the fat content. So that I already explained that to you. But for option number C here, Swiss chalet quarter chicken breast was that first outlier, and a Swiss chalet garden salad. They shouldn't be removed. Why? Because they're part of the data. Okay, we want to explain it. Okay, so you're getting low energy with a high fat content, I think, on one of them. A low fat content. So let's look at the graph. Describe what you can learn from the scatter plot. Well, overall, the higher the fat content, the greater the energy. But let's go back to our GDC for a second, because I think something that is showing us there, this here on the x-axis, we said we had, let me move this here. On the x-axis, here we go. On the x-axis, we had the fat per gram. Okay, so we have low fat per gram. That one's just kind of a little bit out of whack. And then this one here is going to be the Swiss chalet salad. It's got high fat per gram, but it's not giving as much energy. That's not really good. You want to have a high fat content and no energy. So it's just an outlier, not a big deal, but we'll explain it. You can explain it away by just saying that's part of the data, and so we're including it. We don't want to just take it out. But when you're doing your line of best fit, that's when it's important to consider. You're not going to consider the outliers when you're drawing a line of best fit. You still want an equal number of dots above and below, but you're not considering the outlier. There's only 1 or 2 here, so we would just draw our line of best fit accordingly. So for example, if I had something like this and my data is like in this scatter plot pattern like that, and then I got this one guy out here, when I'm drawing my line of best fit, I'm still drawing it there. I'm not going to move it over because that one dot skews the results. Absolutely not. But we will explain this later and say there happened to be one outlier for some reason. Okay, so just keep that in mind. What can you learn? So the higher, like I said before, the higher the energy the higher the fat content, the higher the energy you're going to get, the greater the energy you're going to get. All right. So that's the lesson for today, guys. We'll see you next class. Take care.